Good morning, students. I am Dr. M.Maria Julie, Assistant Professor, Department of Physics, St.Joseph College of Arts and Science, Autonomous, Cuddalore. Today I am going to talk about light emitting diode. First, have to see history of light emitting diode. A short review of LED history. In the year 1927, Optic was created the first LED and published some theory on his research. In the year 1952, Professor Kurte has tested the theories of losses theories and explained about the first LEDs. In the year 1958, the first LED was inverted. And the year 1962, a red LED was developed. And in the year 1964, IBM implemented LEDs on a circuit board for the first time on a computer. In the year 1968, HP started using LED in calculators. In the year 1971, Jacques and Edward Miller were inverted a blue LED. In the year 1972, M. George was inverted the yellow color LED. And in the year 1986, Walton and Herbert from the University of Stafford inverted a blue color LED. In the year 1993, Hirschow, physicist, developed high quality blue color LED. In the year 2022, white color LEDs were used for residential purposes. In the year 2008, LED light have become very popular in offices, hospitals and schools. In the year 2019, the LEDs have become the main light sources. The LED development is incredible as it is ranged from small indication to light the offices, homes, schools, hospitals, etc. Next, what is diode? A semiconductor device with two terminals, typically allowing the flow of current in one direction. And what is LED? A light emitting diode is a true LED semiconductor light source. It is a PN junction diode which emits light when activated. When a suitable voltage is applied to the LEDs, electrons are able to recombine with electrons, holes within the device and releasing energy in the form of photons. Next, light emitting diode. Light emitting diode is a semiconductor device that emits visible light when electric current passes through it. LED converts electrical energy into light energy. About LED, the most important part of a light emitting diode is the semiconductor chip located in the center of the bulb as shown at the right. The chip has two regions separated by a junction. The P region is dominated by positive electric charges and the N region is dominated by negative electric charges. The junction acts as a barrier to flow of electrons between P and N region. Only when sufficient voltage is applied to the semiconductor chip, the current flow and electrons cross the junction into the P region. Next, working of LED. PN junction convert absorbed light energy into a proportional electric current. The same process is reversed here That is, the PN junction emits light when electrical energy is applied to it. So this phenomenon is generally called as electroluminescence, which can be defined as the emission of light from under the influence of an electric field. The charge carriers recombine in a forward biased PN junction as the electrons cross from N region and recombine with the holes existing in the P region. Free electrons are in the conduction band of energy levels, while holes are in the valence energy band, and the energy level of the holes will be lesser than the energy level of the electrons. Some portion of the energy must be dissipated in order to recombine the electrons and holes. This energy is emitted in the form of heat and light. The electrons dissipate energy in the form of heat for silicon and germanium diodes, but in gallium arsenide phosphate and gallium phosphate semiconductors, the electrons dissipate energy by emitting photons. If the semiconductor is translucent, the junction becomes the source of light as it is emitted, thus becoming a light emitting diode. But when the junction is reverse biased, no light will be produced by the LED. On the contrary, the device may also be damaged working. This is the inner workings of an LED showing in the circuit. Next, applications of LED. Sensor applications, second one mobile applications, and third one sign applications, and fourth one LED signals and illuminations of indicators. Thank you.